Okay, so we're going to go over optimization problems. The first one we're going to go over is optimal area. Okay, so we've been given this question. We need to help this farmer. A farmer has 800 meters of fencing, and he wishes to enclose a rectangular field. One side of the field is against a country road that is already fenced. Okay. The farmer wants to enclose the maximum possible area and to use all the fencing possible. How does he determine the dimensions and what are they? Okay, so we're looking for maximum possible area. We're going to make up questions in order to figure this out. We need to make up some equations for this. So we know his perimeter, or the amount of fencing he's working with, is 800. Let's try to draw a picture of what's going on here. So there's some country road. We'll make that green. Here goes the country road. That's the fencing for that. He has his fencing. Okay. And what he needs to do is build a width, a length, and another width. This will create our rectangle for us. Okay. Well, that means he needs 3 sides, but 2 of the sides are going to be the same. Specifically, if we're working with area, we know that we'll call this the width, and we'll give it the variable of x. Okay. We know that both the widths will be the same, and then the length we're going to have to give some equation. Okay, so we know the area of a rectangular shape is our length times our width. In this case, our width is given as x. We also know the max amount of fencing this farmer has is 800. So this 800 is going to encompass this entire fence here. So all of this added together will be 800. So what we can do is kind of work with our perimeter here. Okay, 800 technically stands for the perimeter. Our perimeter will be, in this case, we're going to call this our length. Our length plus 2 of our widths. Okay. We know that width is denoted by x, so we're going to call that 2x. We don't know what our length is yet, and we know the perimeter of the fence is 800. Okay. So since we have that information, we're going to reorganize this in terms of length. We know that length will now be equal to 800 subtract 2x. Zoom in a little now. Okay. Let's make that a little more legible. So like we said, it's going to be 800 minus 2x will now be our length. Okay. So we're going to use that as our length formula. The length of this will be 800 subtract 2x. Okay, so we used perimeter to find out what the distance or the other side of this rectangle is going to be. Which means now, area and width. Our width is x. Our length is 800 minus 2x. Okay, and the goal of this was to maximize our area. So our area formula, which we've now made, is x times 800 minus 2x. Okay. We don't know what the area is going to be, but we do need to maximize this. So we're going to distribute what we have here, and our area formula is going to be 800x minus 2x squared. Okay. Now this is some quadratic technically. Okay, it's going to make some parabola on a graph, and to maximize, we're looking for turning points on a graph. Remember? So let's assume we're going to draw a rough sketch of what this might look like. We probably have something like this, okay, in terms of our graph of this. And you don't technically have to know what the graph looks like, but it's important to realize that when we're talking about a maximum point, which we talked about in the last lesson, we're looking for when the slope of this sketched curve is going to be 0. In other words, when the tangent is 0. So we're looking for a turning point, okay, something like that. So in order to find that turning point, or when the slope is 0, we derive this function and set it equal to 0. So we're going to find area prime, okay? And the area for this, or when we derive it, we're going to end up with negative 4x plus 800, okay? We're going to have to make some parameters to this question too. We have our derivative. We know that the width of this has to at least be greater than 0. Okay, we know that 0 technically can't be part of it. Let's kind of make that here. For instance, if the widths of these were 0, it wouldn't exist. That means there's no widths of the fence. So we know our x has to be larger than 0. And a maximum. We got to figure out what our maximum is going to be here. Okay, so in other words, we can't have an area of 0. Okay, so what we've technically done here is found areas of 0. One way you can do this is we take our area. We're going to take this part of the area formula to make our parameters. Right? We've already had it factored here. We had x 800 minus 2x. Okay. Well, we can't have an area of 0. So if we plug 0 in for that area, this will help us find parameters. Well, that gives us 0 is equal to x times 800 minus 2x. So we're going to split this. What are our two values, or what is going to be our highest and lowest values of the widths of this fence? So we know x at 0 will probably be our minimum, and 0 equals 800 minus 2x. That gives us 2x is equal to 800. X is 400. So we know x has to be between 0 and 400. Those are going to be our parameters for this type of fencing. Okay? Let's get that all in there. Okay. So there's a lot of information we've just put out. We had to create our own formula. That's why we drew our picture. It helped us out. Then we had to set our parameters. We didn't do the parameters with the derivative. We set the parameters with the original function by factoring it. We factored, set it equal to 0. We know we can't have an area of 0. That's definitely not going to be a maximum. So that's going to be our lowest and highest values for x. Okay? And again, like we said, we need to find tangents to this. So now what we're going to do is we're going to take our derivative formula. I'm going to move it over here. A prime equals negative 4x plus 800. And we're going to set it equal to 0. That's going to help us find a tangent to this curve. So when the slope is 0, negative 4x plus 800, we solve for x. We'll get negative 800 equals negative 4x. X is equal to 200. Yeah. X is equal to 200. So that's the turning point on this graph, at 200. Now, remember what we talked about in our other one, in our last lesson there. Assuming this is on an interval, it's starting at 0, ending at 400, and we know we have a turning point, or slope of 0 at 200. Those are going to be the 3 points we're going to plug into our original formula. So we're going to be finding, and really I should have made this a of x, okay? Because this is area in reference to a variable x. So we're going to be finding our a at x, which our original formula was, I think I wrote it up above, 800x minus 2x. Okay, so 800x minus 2x squared. We need to find a at x when x is equal to the lowest point, which is 0, our turning point, which is 200, we just found that, and our highest point, which is 400. We're looking for a maximum. Technically, I can plug 0 in and 400 in just to test them, because technically that's what we need to do. We need to test all 3 of these, the starting, ending point, and any turning points in between. But we already know 0 and 400 are going to produce what for area? 0. Is there any way that would be the maximum fencing? Logically, they just don't make sense. If we plug in a 0 width, we don't have an enclosed area, so in real life that makes no sense, an area of 0, or sorry, a width of 0 or a width of 400. So we could test them, and we know our area is just going to equal 0. There's really no need to. So what we really want to test here is our a of 200. If you're unsure, feel free to test a at 0. We already know it's going to equal 0. And a at 400, we already know it's going to equal 0 again. So those are definitely not it. There'll be minimums, but they're not maximums. A at 200 is going to give us 800 times 200 minus 2 times 200 squared. Okay. This is going to give us 16 with 4 zeros. So that will give us Negative 2 times 4 with 4 zeros, 40,000. So 160,000 minus 80,000. 80,000. Okay. And did they say if it was meters? Meters. So our max area is 80,000 meters squared. What was my width? Anyone know? 200. Okay, that was what our x was. Because remember, width was equal to x. Well, our x was 200. Therefore, our width is 200 meters. I've got my width. I've got my area. I am missing one thing. If I'm to build this fence, what else do I need? Length. I need the length of this fence. Well, our length formula was equal to, you scroll back up and take a look, 800 minus 2x. 800 minus 2x. Well, x was 200, so our length is equal to 800 minus 2 times 200 is equal to 400, our length. So, let's recreate that little picture we had at the beginning. This is our country road that's already fenced across. Our width, okay, our width is 200, which means this width is 200. And the length we had found was 400. Well, when we add 200 plus 400 plus 200, we get our total perimeter of 800 meters. That's perfect. He used all of the fencing. We maximized the area at 80,000 meters squared. Okay? Now, this is a question of maximizing area with a three-sided rectangular shape. Does anyone know what the optimal area always is in this? In terms of length to width. What did we just find? Our length was how much greater, or how many times greater than our width? 2 times. I'm going to tell you this right now, okay? In terms of shapes. This is always optimal when we have a three-sided rectangular shape. It is always, the optimal sides of it are like this. So when you go about doing this in your questions, you should solve it using the math we've done before, but make sure that your widths and your length is 2 times each of those widths. That is optimal in terms of geometry. Anyone know what the optimal rectangular shape is? A square. If I ever ask you for a 4-sided shape, you should come out with an answer. Oh gosh, hopefully this I can make this go. Oh good. That will be this. Okay. If we ever ask you for a 4-sided shape, you should come out with a square. And then the million-dollar question, what is the most optimal shape for area? Is that it? Circle. Circle is technically the most optimal shape. So in case they never taught you that with geometry, I know they really never get into it in academic math, but they do in the applied and college level stuff. It's good to know in terms of checking your answers. So if they ever ask you to optimize a shape in terms of area, you should be using a circle. Okay? And in 3-dimensional space, what does that mean then? A sphere. You guys are geniuses. Good. Okay. So that's optimal area. Quite a bit of work, especially in terms of creating the equation.